The following video is one more time where we get to talk about trig function transformations when we're graphing them. So let's graph y equals cotangent of 3x. Just like in the last video when we were talking about tangent, we do, we do the key point from x equals 0. Now, when we're talking about cotangent, that's not that bad because when we look at the graph of cotangent, um, the graph of cotangent has asymptotes at 0, and so it has an asymptote at 0 and pi, and then the graph crosses x equals pi halves, and it's basically the inverse of tangent. And so when we see where tangent was 0, cotangent is going to go off to infinity and have an asymptote. There is no vertical shift in this graph. There's no phase shift in this graph. The amplitude is not really something that we deal with in a cotangent graph. The range is negative infinity to infinity. The domain we'll deal with after we figure out what the graph is. Then the period, well, the period of a typical tangent or cotangent graph is pi. So we're going to divide this by 3 because my b value is 3. So my period's pi thirds. So if I look at the graph, I have no shifts of any kind. So I have an asymptote at 0. And then my other asymptote is normally at pi, but since my period got moved, it's going to now be at pi thirds. And then my cotangent graph, that was terribly drawn. My cotangent graph will cross in the middle, and I need to figure out what my other points are. So if I look at this, I have pi thirds as my period, and then I divide that by 4 to get pi over 12, and that's what I add every time. So pi over 12, 2 pi over 12 is pi sixths, then 3 pi over 12 is pi fourths, and then I have pi over 3. And once again, it would repeat forever and ever. The domain is, it looks like the restrictions are going to be pretty easy. That appears to be happening every pi over 3, because if I kept going with this pattern, I would add another pi over 12 every 4 times, and I would get to 2 pi over 3 here, and so on. It would be the same for the negatives. So it's all reals except k pi thirds. So every k pi thirds, it doesn't work. We have 2 more problems. I notice, first thing I notice is that the 4 is not factored out, so I'm going to rewrite this. So 5 times the sine of 4x minus pi over 2. What happens when I factor out a 4 from a 2? I get 1/2. So it'd be 1/2 pi, or pi over 2, minus 7. Vertical shift, down 7. Phase shift, right pi halves. Amplitude is 5. The period is, well, normally 2 pi, but I'm dividing by 4, so I end up with pi over 2 as my period. Domain of every sine or cosine is negative infinity to infinity. And the range, I'm going to look at my vertical shift. I have an amplitude of 5, so I go from negative 12 to negative 2. And that ends up being that. So now I look at the graph. It's a positive sine graph, so it will look something like that. And then I went right pi halves, and my period's pi halves, and then I divide that by 4 to get what I add every time. So I'm going to add pi over 8 every time. So pi over 2 is really 4 pi over 8 for those of us that don't like fractions that much. So 5 pi over 8, 6 pi over 8, which is the same thing as 3 pi fourths, 7 pi over 8, and 8 pi over 8, which ends up being pi. Finally, once again, I see that I have something that's not factored out. So y equals negative 3 cosine of 3, that should be an x. or else that would not really be that interesting to graph. It would actually just be a constant. So x minus 4/3 pi plus 5. So I factored out a 3 and I get 4/3 pi over there. Vertical shift, up 5. Phase shift will be to the right, 4 pi over 3. Amplitude is 3, but again, negative, and oh, that would be a positive cosine graph. So I'm going to graph a negative cosine graph just to make sure that I don't do it wrong. The period is normally 2 pi, but I have this 3 here, so it's going to be 2 pi over 3. The domain, always negative infinity to infinity. And then my range is from 2 to 8. Okay, so now let's figure out what's happening. I went right 4 pi thirds, and my period is 2 pi thirds. So I'm going to take 2 pi over 3 and divide that by 4. So 3 and 4 multiplied together is 12. So I'm going to add pi over 6 every time. For those of us that don't like fractions, 8 pi over 6 is what 4 pi over 3 is. So this becomes 9 pi over 6, which is 3 pi halves, 10 pi over 6, which is 5 pi thirds, 11 pi over 6, and 12 pi over 6, which is 2 pi. And so that basically ends up being what my x values are. Write the equation of each of the following graphs. So now we're going to work backwards. And I'm actually going to write a lot of different equations here, just to kind of make sure that we're on the same page. I'm going to write a positive sine equation, a positive cosine equation. I'm going to write a negative sine equation. So I'll put a star to remind myself that that's what I'm doing. And a negative cosine equation. So let's kind of figure out what all these things would be. First, let's find the midline. So it looks like we're going from -1 to 5. The midline appears to be at 2. So half the graph is above that midline, half the graph is below. So what I want is, if I want to write a positive sine equation, I have to make sure that the graph starts by going up and then has one complete cycle, and then that can kind of help me figure out what's going on. So if I look at this, what I have is I need to figure out what this green point is. And it's actually not that hard, because it looks like I'm going from 0 to pi over 2. And so the midline would be right in the middle of that. So my my x value, where I start my positive sine graph, would be at pi over 4. So let's kind of just decompress this. I have a vertical shift up 2. I have the horizontal shift, or the phase shift, is going to totally depend on whether I write it as a sine or a cosine graph. My amplitude is 3. And I shouldn't write a positive, but my amplitude is 3. So this will really help me as I'm like writing these things. And then I kind of have to figure out what my period is. And it looks like my period, if I look at one complete cycle, and I could look at a complete cycle from anywhere, but if I look at a complete cycle, it looks like it is, looks like, I mean, this was negative pi over 2 here. This would be negative 3 pi over 2, and then it goes from pi over 2 to 3 pi over 2. It looks like a cycle is pi. So my period is pi. Now the normal period is 2 pi, remember? So that means, what does b have to be? Well, if the period is pi, and I know that I have 2 pi over b to kind of like, I normally put b down there and then I end up getting the period. Well, I can just do a little bit of math, and I figure out what b is. So b ends up being 2. So my period being pi means that my b value is 2. So now I can start to write these things. The amplitude is 3. That's not really going to change for any of these. Now I could make it negative, but the amplitude is going to be 3. Um, my sine graph, my cosine graph, my negative sine graph, and my negative cosine graph are all going to have a b value of 2. My vertical shift is 2. So I'm going to add 2 to the end of all these. So basically, everything kind of looks the same. The only thing that's different is where we start. So the first thing that I did was I looked at my sine graph, my positive sine graph, and I'm starting at pi over 4. So that means I have a right shift of pi over 4, which means that I write x minus pi over 4. Now, I could have started in a variety of different places. I could have started at this point, or that point, or this point. Those would all start positive sine graphs. But I'm not going to write it an infinite number of times. So we have one positive sine graph that I'm going to write. We could have done it in a variety of different ways. A positive cosine graph looks like it would start at pi over 2, or it could start at negative pi over 2. I mean, I have a variety of different choices. I'll use the positive one. So x minus pi over 2. I could have chosen plus pi over 2, because that would also be a positive sine graph. A negative sine graph looks like it's going to start here, and right between pi over 2 and pi is 3 pi over 4. So I can say x minus 3 pi over 4. I don't know what happened. I must have hit too many buttons. I also could do a negative cosine graph. That starts at 0. I could just put x. I could also have it starting at pi or negative pi. I have a variety of different options, but these are all ways that I could write this equation. Let's do another example. It looks like one complete cycle is 8, and my normal graph is 2 pi. So 2 pi over b equals 8. So b has to equal pi over 4. So let's write a cosine graph really simply, because I know that I can write a positive cosine graph with no problem. So y equals, well, where's the midline? Well, if I'm going from negative 3 to 5, the midline has to be at 1, because that's the average of 5 and negative 3. So my vertical shift is 1. So I can put a plus 1 at the end. My amplitude is 4. So I can put a 4 in front. I'm going to have a positive cosine. I should probably move this plus 1 a little bit so that I have a little bit more room for my parentheses. And then now what I have to do is I kind of have to figure out what the b is. Oh, I already figured out b. B is pi over 4. So I put pi over 4. And now I just have to figure out where my shift is. Well, my cosine graph doesn't have a left or right shift, so I can just kind of leave it like this. What if I wanted to write it as a negative cosine graph? Negative 4 cosine. The b value stays the same. I look at what my shift is. My shift is left 4. So I put x minus 4. I could have a variety of different situations where I have this happen. What if I wanted to write a negative sine graph? There's something that starts at negative 2. If I want to write a positive sine graph, 4 sine pi over 4, and then I figure out where it is. It looks like that's a left shift of 2. I also could do a right shift of 6, but I'll do the left shift of 2. So I have x plus 2. And I just wrote a bunch of different examples here. I want you guys to pause the video, try this, and then see if you get one of the answers that ends up working out. And pause the video, and then I'll just write a bunch of answers after that. So my midline or vertical shift is going to be -3. It looks like my amplitude is 2. And then my period goes from, it looks like pi over 2 to 5 pi over 6 is half of a period. So the whole period, well, pi over 2 is the same thing as 3 pi over 6. So that means that at the top of this would again be 7 pi over 6, -1. Um, and then, so that means that my period appears to be 4 pi over 6 or 2 pi over 3. So I'm going to write two different examples of these, and you could probably have a lot of different ones. But I will write a positive cosine graph. So my amplitude is 2, cosine, my period is 2 pi over 3. So now I have to figure out what b is. So 2 pi over 3 equals, b equals 2 pi divided by 2 pi over 3, which if I manipulate, I end up getting b equals 3. So that means I have 3 times x minus pi over 2 minus 3. That's a positive cosine graph. I'll write a positive sine graph as well. This is going to be the positive sine graph that I write. If I look at how far things are going, like 3 pi over 6 to 5 pi over 6 means that each like tick mark that we would have would be another pi over 6. So this would be like 4 pi over 6, and then this point would be 2 pi over 6, which equals pi over 3. So I'm going to use pi over 3 as an example. So 2 sine 3 times x minus pi thirds minus 3 would be an example of a positive sine graph. There are tons of different ways that you can do it. If you had a different answer than me, you can put either one of these two graphs into Desmos and then type your answer in and see if you get the exact same graph. If you do, then you're a winner. If not, then you have to evaluate like why or what did I mess up there.